Hello, good morning to our Taiwan participants and also the good evening for US participants. Let me introduce myself. My name is Carl Ho. I'm the host of the Data Analytics Colloquium. And today I'm really privileged and excited to introduce Professor Guy Whitten from the University from Texas A&M University. And he is the professor of the full professor and also the department head of political science in the Booth School of Public Policy and Public Service at Texas A&M University. And he is also a chair professor as the Bob Bullitt Chair in Public Policy and Finance. And allow me to introduce a little bit about his background and also his research. And Dr. Whitten is a great friend and it's the second time he's presenting his research on the theory and also the methodology of dynamic pi. And he's going to talk about some recent advances in this direction. It's a really interesting method. And his interest of teaching and research is comparative public policy, but he's better known as a political methodologist. And much of his works and have been published in Europe and US, and he's do across national comparative studies of influence economics on government popularity and elections. And most recently, he has a co-author book titled "The Politics of Budgets: Getting a Piece of the Pie," written by Professor Christine Nipsmeyer and his student Andrew Phillips, and published by the Cambridge University Press in 2023. So he has a long list of publication. I think I will not read out, and it may take some time. And he is currently also have a center on European studies at Texas A&M, and his work has been published in multiple channels. And all right, and without further ado, let me introduce Professor Guy Whitten. Hello, Dr. Whitten. Please go ahead.
Hey, thank you very much, Carl. I can't see anybody, so I hope you can see my slides. Thank you
Yes,
for the
I
very
can.
kind. Okay, thank you,
Yeah.
Carl. Yeah, thank you for the very kind introduction as well. Really appreciate it, and it's a pleasure to be here to talk about my work today. To be in Taiwan in person sometime before too long.
We must bring you here.
Yeah, that would be wonderful. That'd be wonderful. Um, yeah, so this is something that I love talking about. The Dynamic Pi project is almost 10 years old now, which is kind of hard for me to believe. The time has gone really fast. Um, but what I am talking about in this project it's really a project where methods help drive our theories to be more realistic, and then our theories drive the methods. So it's kind of an endogenous process where we can begin to theorize more closely to what goes on in the real world through these types of models. And they're all about the dynamics of trade-off relationships. And that's kind of a theme that runs through this entire project. Um, and so what I'm going to do tonight is just give you guys some background about the Dynamic Pi project, kind of talk about initial ideas came from, and show you some examples from the early papers in software, talk about some of the extensions that we've done, and then really focus on two projects that we have that are in the kind of advanced stages. One that we call Selection Pi, where we address a problem that's plagued analyses of election results all over the world, and it's the problem of what we call partial contestation, or the idea that not every party contests every district. And we're able to, with this new model that we have, we're able to model this in two stages, both whether or not the parties contest a particular district and then what happens in that district. And we'll talk about, why that's important and how that matters a little bit tonight. And then the other one is called endogenous pi, where we're looking at compositional variables as part of a vector autoregressive system of equations. So VAR models and including compositional variables in them. But like I said before we get to those two newer projects, what I'd like to talk about is the origins of this project and some critical background concepts. I know you can see it looks like I have 76 slides. I promise you it's not going to be that long a talk. And there's some slides that at the end that are just there in case people want to see them in the Q&A. And then there's some slides that we'll go through very fast. And also, I'm happy if you guys would like to get a copy of these slides, I'm happy to make them available. So getting to where this project started, this is some work that I was doing about 13 years ago, well, really longer than that, probably about 15 years ago, where we were looking at vote intention in the United Kingdom, and this is during the period of Labour government under Tony Blair and then Gordon Brown, and this is data that was made famous by advisor Harold Clark. And what we did, my co-author Harvey Palmer and I, we were just modeling different income groups and how they responded to changes in the macroeconomy in terms of their support for the Labor Party. And around that same time, I was doing a bunch of work on political budgeting. And this is from a paper that I published with Larry Williams in the American Journal of Political Science called Buttery Guns and Welfare Hawks. It's all about defense spending. So the public opinion one is a single unit time series. This one is a time series cross-sectional model looking at advanced industrial democracies, and I recognized that both of these projects had kind of a similar problem, and it reminded me of some really old work that I had also done with Harvey Palmer, and this is from a paper that we published in 1996, which many people have told me, and I think it's true, was the first paper in all of political science that used a multinomial logit model. And we were in this project, this is just cross-sectional data. And so you're probably wondering, how do these things all fit together? I'm getting to it. But basically, what was going on at the time was people would model the election results in multi-party elections, and they would lump the dependent variable into two categories and do a binomial logit or a binomial probit model, where the dependent variable was whether the respondent voted for the government or the opposition. So 1 if they voted for the government, 0 if they voted for the opposition. And very standard model. This is using the Dutch election results from 1986, and you could do a graph. Which back then this was kind of fancy, graphing results from a binomial logit, and we can see across the horizontal axis we've got a hypothetical individual's left-right self-placement from far left to far right, and then on the vertical axis we have the predicted probability that they'll vote for the government, for one of the parties of the government. And not too surprisingly, since this is a government of the center right, what we see is that as this hypothetical individual becomes more right wing, their probability of voting for the government goes up. And there's, nothing really wrong with this model or with this graph, but what we said was, well, there's a lot of subtlety to Dutch politics
Mm-hmm.
that this model misses, and so we proposed the multinomial logit model, which you can see now we've got, instead of just one column of parameter estimates, we've got six, and we're able to uh, get a much more subtle and nuanced look at the effect of variables like ideology on people's probability of voting for in the Netherlands. And so we produced a graph like this, where we can see as a hypothetical individual moves from left to right, their probability of voting for the different parties goes up and down. And so
Mm-hmm.
PVDA is the Dutch Labour Party,
Mm-hmm.
and so they're a party of the left, center left, and we can see that their probability is big, and then it gets smaller. That space in here gets smaller as the hypothetical individual moves to the right. D66, which is a party of the center, we see bulges out in the middle, and then it gets a smaller probability on either tail. The small left parties, which are pretty far left, they only have a chance of voting for them when the individual is out on the far left. Orthodox religious right, like the most right-wing parties back then, we can see there's only a sliver of probability when the hypothetical individual, is on the right. And then here's the two parties of government, the Christian Democrats and the Liberals, the VVD, and we can see that even between them, there's some real differences where the Christian Democrats are more to the center, so their uh, probability, that hypothetical individual's probability, tails off when we go to either extreme and is highest out here in the center right. And then the Dutch liberals, who are fairly right of center, their probability gets largest when this hypothetical individual is on the far right. And just to kind of bottom line it, what we're able to do by moving from a binomial logit model to a multinomial logit model is to get a much richer picture of Dutch politics. And if you talk to an expert about of Dutch politics, this is exactly what it looks like. This is exactly how we think about the way things work. And it's a country where the ordinary citizens know a lot about the political parties, and this is just a much richer picture using the exact same data, but doing a multinomial logit instead of a binomial logit. Okay, so going, kind of back to where we left off, was going on in my other projects that was similar to that work, is that if we're thinking about 2000s, um, of course, we know that there's not just one party. There's really three or four parties, depending on how you count them, in the UK. And so we know the other major party, of course, is the Conservatives, but there's also the Liberal Democrats, and there's the beginning of the UKIP party, and a few other parties, Green Party, and so on. And so what we were doing in our time series model was very similar to what people had done before with their binomial logits, which is kind of collapsing the world into two categories. And so if we think about that in a kind of a visualization of the data, what we were doing was essentially saying, we're modeling this orange thing, and then everything else is lumped into the blue. So it's the orange sliver against everything else, and we're modeling that over time. And there's nothing wrong with that per se, but it's a little bit, it's a little, simplified, that we're kind of lumping everything else together in this blue area, and we might be missing some of the subtleties of politics. And so, when we think about um, what happens in the media when there's a major political event in a country that has more than two political parties, so a country not like the United States, um, people immediately think about competitive dynamics in terms of all of the major parties. And so, as an example of this, if we think about this is an event, this is right after the Brexit vote in the United Kingdom, there was a huge surge for the National Rally Party, which is, of course, the party of Marine Le Pen, who we're looking at right here. And so she had a big surge of support. And then this article, uh, basically, what did it talk about? It talked about where was that support coming from. Some of it was coming from the socialists, some of it was coming from the Republican, and then some of it was coming from other parties in France. And so the journalists, think about French politics in terms of all of the different parties. And when one party gains, one of the first things they start writing about is who's at whose expense, which parties are losing in response to the gains by the National Front and Marine Le Pen. So what we're essentially saying is that political scientists had been modeling the world this way when in reality the world looks more like this. Okay, and this is where we got the idea of the dynamic. These are essentially pie charts, um, which of course are graphs that statisticians are very critical of. They like everything to be done in histograms, but um, you know the idea here is let's model these compositions across time, and let's model all of the components of the composition, not just one slice lumping everything else together. Um, and and I I pitched this project to some of my graduate students at the time at Texas A&M, and they really took off with this. And the two first graduate students that I worked with are Andrew Phillips and Amanda Rutherford. Uh, Andy now is a associate professor at University of Colorado Boulder, uh, and Amanda is an associate professor at Indiana University in the O'Neill School. And they both have endowed associate professor positions, so they're doing great. Um, Later on, we started working with Yusun Jung, who's now at Trinity University in Ireland on a tenure track position, and then Flavio Souza, who is now working for as a consultant for Bain, the famous American consulting company. So he got lured away by the private sector, um, and they're all doing really well. But uh, in the beginning, it was I was working with Andy and Amanda, and I told them about my idea in really rough and vague terms, and they went out and found all kinds of amazing literature from fields like geology
Mhm.
and really far-flung fields of inquiry, and one of the most important pieces was some work by a statistician, a Scottish statistician, John Aitchison. And Aitchison had developed a pretty model to use for compositional outcome variables. And he had done most of his applications in geology, So the idea is like you pull a sample from the Earth uh, down. What's the makeup of that the dirt that you pull up? Is it soil? Is it rock? That kind of thing. Um, and so what they hadn't done a lot of was work with time series data and very few examples that they had applied to social science data. So we saw a real opportunity there to take what they had done, and so that begat the Dynamic Pi project, and once you start thinking about the world this way,
Mm-hmm.
uh, you
Mm-hmm.
start to see that we have compositional variables,
Yeah.
everywhere in the social world,
Hello,
um,
guy.
and
Hello.
yeah,
Hi.
yeah. Can you
Do
hear
you
me?
see? Yeah, great. I want to do one check. Do you see
Yeah.
the hands up and also you may not see the checkbox, right? I want to double
I
check
don't
that.
see anything like that.
Checkbox.
I'm sorry.
Okay, sorry. Then if students have questions and if you want to
Yeah.
type it
No, I'd be happy to take them.
on the chat box, I will do the relay. Then or you
Yeah,
can
yeah,
speak
yeah.
up too
So
if you like to.
let's
Yeah,
yeah, let's get the
yeah,
question, please.
yeah. If you, I hope you do not mind interjection like this. Yeah. Then I
No,
have a
no,
quick
not at all,
question.
Carl.
Yeah.
Yeah,
Thank
please.
you. Yeah, I have a quick question. I think this is really groundbreaking it was groundbreaking when you first introduced to us to the colloquium, like maybe a couple of years ago, and now this is a much more advanced. And because also, I want to say congratulations to your students, particularly Andy. We invited Andy to give a talk. Do you remember? And I cite his work a lot in the class when I talk about time series in my data science class, and it's really exemplary. Congratulations to him to get the tenure already. Now, I have a substantive question.
Yeah,
So,
yeah.
and actually very interesting when you see this and then put it into the pies, and of course we would learn more about dynamics of the pies. Now, how do you deal with cases? For example, some parties may have uh, issue request, not exactly fully overlap, but still like some areas they may share some issues somewhat, not mutually exclusive. For example, like social democrats, like or like a leftist parties like a labor, and do you also account for those changes or those presentations?
So, you mean if they change their issue positions, or
Um,
like if just two parties are similar to each other?
Yeah, this kind of similarities or differences should be changing over time. This is the purpose. You teach us soon about the dynamics, but there should be some at a certain point of time, and it could be some very different with some very somewhat similar. Do you account for those similarities? And when it comes to, say, for example, budgets for lower class populations, yeah.
Yeah, I mean, so the I mean anything that you can think about theoretically you can account for in these models. It
Hmm.
just
Yeah.
it just depends on how you're thinking about it. Um,
Hmm.
the if you think that two parties are kind of indistinguishable in the minds of the voters, then
Hmm.
what we would expect is that there wouldn't be any variables that would predict differences between those two parties. So you'd have kind of a
Uh-huh.
null expectation on
Hmm.
you know the trade-off between those two. Um,
Hmm.
but uh, changing positions of the parties, then we've done some of that, and we did it very preliminarily, but we have ideas about how to model changing positions. It's kind of like the mixed logit model, where you have
Uh-huh. Yeah.
uh,
Hmm. Yeah.
done some very beginning work in that space.
Mm-hmm.
Anything that you can do in a multinomial logit model, essentially mimic that in these dynamic pi models.
Mm-hmm.
The big difference, Carl, is that instead of observing like a categorical outcome, like in your
Yeah.
voting
Mm-hmm.
model,
Yeah.
you observe that they voted for one party and one party only.
Mm-hmm. Mm-hmm.
What you can think about these models as like we get the vote share
Yeah.
uh,
Mm-hmm. Yeah.
for everybody in that district, or
Mm-hmm.
you know, so so it's kind of like we have richer data, if you
Mm-hmm.
will,
Mm-hmm.
and yet at the same time, kind of more complicated data
Yeah.
to
Yeah.
just work with mechanically
Mm-hmm.
in the of your model, in the
Mm-hmm.
estimation.
Yeah. Mm-hmm.
Yeah, yeah. No,
That's
really
great.
good question.
Yeah.
Okay, all right. All right. Shall I put the slides back up?
Mm. Yeah. We
Okay,
seriously see
great.
the pie, really fancy
Oh,
pies.
you still see it?
Yeah, so you
Okay.
see that. I think this is the I do not have the number of the pages.
Okay.
Yeah, see
Yeah.
that. Yeah, you're moving it now. Yeah.
Okay. Good. Okay. So, um, let's see. I don't know how to. Okay. Is that big enough for you guys?
Let me see, and maybe
Because
it's
this
just
way I
me.
can actually,
Yeah,
I can.
I see the full screen, and but I think individuals can adjust that. I think it's great for me. Yeah, please go ahead.
Okay. Okay. Great. Great. This way I can probably see if you have questions
Hmm.
better. Um, okay. So, let's see. Okay. Um, So just, I'm happy to get into the equations in greater depth if people want. Um, this is these are really slides if you guys want to look at this stuff and get into it more detailed later. A composition, I mean, the characteristics of it are just that, it adds up to a whole at any point in time or for any observation. And so if we're thinking about a compositional time series, each component of the composition has a value between 0 and 1. The components always sum up to 1. Uh, their changes are bounded by -1 and 1, and all the change at any point in time must sum to 0. So, very basic ideas in terms of compositional variables. Um, but the big problem is right down here that the component parts of variables like this can't be handled very well in regular regression models. So uh, there's actually some early political science work on this stuff, and here's some figures that kind of were used for it. I think these are awful figures. They're simplex and then a ternary plot. Anyway, we followed Aitchison's suggestion, which is a log transformation where you choose one category of the composition as your baseline category, much like you would for a multinomial logit model. This is the key part of that. And then in our initial models, we did it as a error correction model. Later models, we did them as ARDLs. I'm happy to talk about the nuances of the time series stuff that we did later on if people are interested. Um, but basically, this is all stuff that we can get into in Q&A if people are interested. You get this big system of equations, a whole lot of numbers, parameter estimates that are of somewhat limited utility, just numerically, but we do post-estimation simulations, and what we did initially was what we call a change from baseline simulation. where where keep everything constant and then change the value of one variable and look at how the values play out across time. So here's an example. Sorry, that's just the numeric representation of what we do. Plays out over time, and then we do the shock to one variable, which then works its way through the entire equation. And this is an example of the output. So up through period 8, we left everything the same, and you can see that the predicted proportions for the three main British parties are all flat, uh, 8. And then in period 9, we did a one standard deviation increase in people's evaluations of the leader of the Liberal Democratic Party. And not too surprisingly, support for that party goes up, and then we see support for both Labor and the Conservative parties goes down, but we see Labor quickly rebounds and support for the Conservatives kind of levels off at a new equilibrium value, which is below. Labor's actually gone up. Liberal Democrats come down a little bit, but then settle into a new equilibrium value that is higher than what the original one was. And so if we think about if we were estimating a time series model of just support for one of these parties, we would be able to get one of these sets of figures, either the red one for conservative, sorry, blue for conservatives, red for Labor, or yellow for the Liberal Democrats. But by doing this in a pie model, using the Aitchison transformation, we're able to model all three components at once, and we get a much richer story, substantive story out of it. And so we were pretty excited about that. We think our graphs are a lot friendlier to interpret than these. These are by Katz and King, Gary King, who's a very nice man. I showed him these graphs and he agreed that ours were better, which is very nice of him. Anyway, and so this was one of the examples that we used in our first paper on this project that we published in the American Journal of Political Science. And that's the paper. And then we also published a paper in the Stata Journal and the software to do those initial models. And 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 then we've done lots and lots of things since then. And I would kind of divide the work into methodological work and then more substantive work. And methodological, the mixed logit type of specification, which Carl just asked about, with the we were Carl, was we modeled parties going in and out of government and looking at how responsive their support was to the economy when they were in government versus out. And not too surprisingly, their support's a lot more responsive to the economy, changes in the economy when they're in government. We to more flexible time series specifications, and we extended it to time series cross-sectional and including spatial econometric specifications. We did some models on compositional volatility. So these are kind of the compositional equivalent to like Arch and Garch models. And then we some new software, which I'll show you in just a second, which produces, I think, much better figures than the original software. And then substantively, two areas that we've done a lot of work on are the study of inequality and comparative political budgeting. And of course, that's my book that Carl mentioned that just came out last year with Cambridge, where we did a whole book on political budgeting, which I'm happy to talk about more if you guys are interested. I'm just going to show you the second piece of software and some of the things that it can do before we dive into the two new projects um, that are in progress. Okay, so here's the second State Journal publication with the two additional new authors, Yusun and Flavio. Um, and it can do a lot of things. These are all the things it can do. Different time series specifications. It can do interactive specifications, which are pretty popular in political science these days. Um, it can do evolving scenarios for change from baseline plots. So if you wanted to show multiple shocks instead of just one shock and watch the system of equations react to that. We do effects plots and coefficients plots, which I'll show you some examples of. Those are all currently available. Some code that's available in the application files for our book project. We need to make that more user friendly, but you can use it. And then other things that are in development are the endogenous pi, which I'm going to show you, the selection pi models, which I'm going to show you, and then we have some ideas about building some R packages as well. All of the software that we've done so far has been in Stata, and obviously people are excited about other, so we need to do that. So this is the old change from baseline graph. This is a different scenario, but this is with the new software. And one of the big changes we did was what we call effects plots. And so this is the exact same scenario as a change from baseline, but then showing it as an effects plot. And so what we get is both a long run and a short run effect, and we can see whether the 99 and 90% confidence intervals cross this zero line. So we can get really a very quick assessment of whether the short and the long run effects are positive, negative, and statistically different from zero. And to see how these two graphs line up together, what you can see is the short run effect here happens at time 5. And so if we're thinking about the green dots, which is for the Conservative Party here, we can see that it's negative. And so the difference between this dot at time period 4 and time period 5 is actually this line in the effects plot. It's a short run effect. And then if we're looking at this long run effect, once it's stabilized, visually, it's kind of hard to say, is this dot different from this dot with the confidence interval through it? And so that's hard to see. But here we can see, no, it's not statistically distinguishable if we use a 95 or a 99% confidence interval. And so you can kind of think of these two graphs are giving us the exact same information, but this one's doing it in much cleaner ways that line up much more with what people tend to think about in hypothesis testing. And these are effects plots. We also did coefficient plots, and remember the coefficients plots are like multinomial logit coefficients. So they really don't lend themselves to easy interpretation beyond saying that the effect is statistically significant or not. And so we really would rather do these effects plots, but the coefficients plots are a good way to kind of get an initial handle on what's going on in your model. And we have several different versions of those that you can do. And anyway, I do think that these effects plots are by far the best. But anyway, I'm happy to talk about that more if you guys are interested. Um, but now I want to turn to what we call the selection pi models. And I know I'm a little slow here on time, but the idea here is that we want to deal with selection effects in multi-party elections. So I'll explain what that is. Um, and and to understand why we're interested in this, what we can see is that uh, this is looking using constituency level elections archive data, CLE data, to look at partial contestation around the world. And what we can see is about 26, 27% of elections in their data set have no partial contestation, meaning all the parties that contested the election contested every district, every electoral district. But that means that almost 3/4 of the elections in their data set, there was some version of partial contestation. And so here, that this is looking at elections where between 1 and 25% of the seats were districts were partially contested. On average, they had three different patterns of contestation. Here, going on up to 100% of the districts were partially contested, 7.5 different distinct forms of contestation. But the big point is most elections for national legislatures around the world are partially contested. And we need to think about um, you know taking that into account in our models of district level outcomes. Okay, well, what people suggest are pretty unwieldy or likely problematic solutions. Um, One thing that they do is they just model one party's vote shares across districts. So they do a non-compositional model. Another thing they do is they do a compositional model with only the fully contested districts. So they assume that those districts are representative of the rest of the country, only those districts in which every party competed, and that seems a little suspicious to me. Another thing you can do is add a tiny value. So if a party didn't contest a district, pretend like they did and assign them a tiny percentage of the vote. Um, and we've done some, um, well, that's another thing you can do, or you can estimate a separate model for each pattern of contestation. So for each set of districts that had a particular pattern, all of these things have their own problems with them. And we've done a bunch of Monte Carlo analyses with simulated data that show that unless parties just choose which districts they're going to contest randomly, you get big errors, big biases in your model estimates. And I think it's pretty easy to imagine that parties that don't contest every district, that they're not doing that randomly. They in most districts you have to pay a deposit, you have to find a candidate to run, and so when you don't have enough resources to run in every district, you're probably choosing those districts strategically. And I don't think that's too wild an idea. Um, so basically, unless the selection phase is the errors from that phase are uncorrelated with those in the outcome, the voting phase, then you're going to sample selection problem very much like the one that Heckman brought to people's attention in his very famous 1979 paper on labor markets. And so we propose a maximum likelihood solution to accounting for partial contestation in this paper. And so we have the party votes. We've already talked about them as being compositional, and we can using the Aitchison transformation. Um, we can't use McFadden and Train's solution, which is basically Heckman's, you can't use an inverse Mills ratio because the errors are not normally distributed. Sorry, McFadden and Train's contribution was talking about extreme type 1 errors when you have log ratio outcomes. And so we do a MLE model that allows for non-normal terms. And so we have a selection stage where we're modeling for those parties that didn't contest every district, we're modeling whether or not they contested each district. We have a dummy variable equal to 1 if they contested the district, 0 otherwise. And then we have an outcome stage where it's just the compositional model. And if the party contested, then we are modeling their support in that district. If they didn't, obviously we're not. And the key thing is that we don't impose the restriction that the errors are uncorrelated. We allow the errors to be correlated across these equations and across the selection and the outcome stage. And so our example is, this is our maximum likelihood function, a lot of fun math, which I'm happy to get into if people want to. And so we did an applied example using data from the 2017 and 2019 UK parliamentary elections in England. And these are, the Brexit elections. So they're kind of upside down economic voting, which I'm happy to explain. But when we do the selection stage model for UKIP, the Liberal Democrats, the Greens, and then others, all parties or party groups that didn't compete in every district. Labour and the Conservatives did compete in every English district. And then the outcome stage, the Conservative parties are baseline party. And we find that the error correlations across our models, across the stages, are extremely high. 0.9 correlation for UKIP, 0.64 for the Liberal Democrats, 0.88 for the Greens, and 0.74 for the others. What that means is that if you ignore this stage in your model and you just assume that the errors are uncorrelated, these errors are going to be highly, highly problematic. And so, this was meant that all this maximum likelihood machinery that we had done was worth the.
Hello, Guy.
And so, yeah, sure.
Okay.
Carl,
So
yeah.
this is extremely interesting. So these error correlations are pairwise or just a group wise?
So it's party wise. Okay,
Party-wise.
so the models, the data structure is party I in district J.
Mm-hmm.
Okay, so
Yeah.
the outcome here is the dummy variable equal to 1 if party I contested district J.
Mm-hmm. Yeah.
Okay,
Mm-hmm.
and then
Yeah.
down here we have the log ratio of party I's vote in district
Okay.
J.
Yeah. It's a baseline.
Relative to the conservatives.
Yes. Mm-hmm.
And
Mm-hmm.
it's a log ratio. Yeah.
Yeah.
And so the errors are between,
Yeah.
so for UKIP, it would be
Mm-hmm.
the error between the selection model equation for UKIP and then the outcome for the log ratio of support for UKIP relative to the conservatives.
Yeah. I'll be interested in the
So
UKIP now reform.
that's the
Reform. Yeah.
Oh, we have UKIP and reform together.
Oh, together already. Okay. You account for that. Yeah.
Yeah, because they had an electoral alliance in
Yeah.
2019. Of course, in
Yeah, 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 yeah.
2017
Yes.
is just UCAP. Yeah.
Yeah, it'd be
But
interesting if we have
yeah,
2024 data. Yeah,
yeah, we're waiting for that, and we're
yeah.
super excited to
Super
get it.
interesting. Super interesting. Yeah, that's
Yeah, thank
interesting.
you,
Yeah,
thank you.
yeah. Great,
No,
great, great.
we were we were really excited
Yeah,
that it makes such a big difference, and
yeah.
and uh, and then here's some of the results. These are just coefficient plots because this is very early, and we just got these results, so you guys are the first audience to see them. Um,
Hmm.
but what we see is that, of course, the parties are strategic. Um,
Uh-huh. Hmm.
so, so here's from the previous election, how far out were you from the second place party? So
Hmm.
from how far away were you from being the top two parties in the top
Uh-huh.
two
Yeah.
in that
Mm.
district? And the further out you are, the Greens, were less likely to contest those districts. All of the negative, as you would expect, meaning that they chose not to contest the elections where they were way out of contention, right? The effect for the others, which of course is a lumping together of lots of different tiny parties,
Hmm.
and the Liberal Democrats are not statistically different from zero,
Uh-huh.
but the UKIP um, uh, stroke Brexit
Hmm.
are negative and the Greens are negative.
Hmm.
And it's exactly what you'd expect, Carl. They're being
Hmm.
strategic, right? I mean,
Yeah, yeah,
they
yes,
only
exactly.
want to
Yeah.
they only want to run in the districts where they have a chance. Here's
Yes, yes,
another measure
yes.
of strategy. What was the distance between the top two parties? You
Hmm.
know, if one party won by, you know, 20%, then you're going to be less likely to want to contest that district because it's a really
Yeah.
strong district for those parties,
Yes, yes.
for that party. And then effective number of parties, the more parties contested the district, the less
Yeah.
likely Greens. And we see that the UKIP and the Lib Dems were more likely to contest those districts that had more unemployed people,
Uh-huh.
and
Yeah.
it makes sense for Brexit, UKIP Brexit, not so much for Lib Dems. I'm not sure why that is,
Hmm.
because they're really much more of a posh party, as you know.
Hmm.
Um,
Yeah, yeah.
but
Mhm.
I mean, on the other, I don't know. Anyway, um, and then if we look at the outcome stage, we get the coefficient plots are very much as we would expect them to be. Districts uh, that had higher house prices were less likely to vote for the conservatives, more likely to vote for the other parties, because by now the conservatives really are the party of the left behind people. So in
Hmm.
districts that haven't been prospering economically, and this is the really the best predictor is house prices changes, and this is consistent with work that Ben Ansell at Oxford and others have done um,
Hmm.
of of voting these two Brexit elections, and then unemployment. We see a big advantage to UKIP. No wonder
Yeah,
they wanted to run in those districts. They
yeah.
tend to do better than them. This is exactly not the districts they should want to be in. So that's a little bit of a puzzle. You know, why were they more likely to want to contest those districts when they were more likely to lose votes? So that is a bit of a puzzle. But
And can I ask one
okay,
more question, Guy?
yeah, of
So
course.
is it, I don't know whether you look into the cannibalizing effect. So this is, for example, like a UKIP or reform is that they're fighting the grab growth and votes from each other. That's cannibalizing each other.
Yeah, I mean, UKIP and Brexit did not contest the same districts. They
Okay.
divided up the map in
Okay.
2019,
Uh-huh.
and so you're probably right in terms of what happened in 2024 because I think they
Yeah.
did
Mhm.
contest the same districts, but we'll have to
That's
wait
right.
until
Yeah,
later.
the new data will be really interesting. You're the
Oh, I
first one
agree.
addressing that, I think.
Yeah, it's really cool.
Yeah, super
Yeah,
interesting.
I'm to see that. Um, and of course, in 2024, we would expect to find of the parties that didn't run a candidate in every district that they were
Hmm.
strategic about where they ran candidates.
Hmm.
Um, okay, and then these are just effects plots, and so these are now in the metric of vote percentage, and they're telling the same story, but they're giving it more readily interpretable metrics in terms of percentage of vote.
Hmm.
Effect of a one standard deviation increase in house prices and unemployment. Um, and then I know I guess what I'll do, uh, you know, we basically found uh, that our model, uh, the other models in Monte Carlo experiments, gives us sensible results, and as we said, the really high error correlations. Future work we want to make this available as software so that people can use it to analyze elections all over the world. Um, and then the endogenous pie, I don't know, maybe I don't really have time to do this one. What do you think, Carl? Can't hear you.
Hello, Guy. I know this is you still have a lot of materials to show, but in the meantime, I think we have a lot of questions too, and this is
Yeah,
because
let's
it's a
do that.
really it's a big project, and
Yeah, yeah,
I
yeah.
have
No, no, of course.
I have multiple
Yeah,
directions of questions they want to ask you to. Maybe we can
great.
stop here to start.
Yeah,
We
that's
have some
perfect. Yeah,
Q&A, if you do not mind.
yeah,
So I
yeah,
believe
not at
that you
all.
can
Not at all.
save your future slides too. And
Yeah,
now
of
let me
course.
check with. I think Peter is here. Peter, and are you? Let me see if I can put you in the spotlight so we can see you also. And let's see. Then I can add myself to now Peter is here. Hi, we know each other. Now except not in okay,
Hi,
now Peter.
Guy.
I
Yeah.
good. Okay, you have
Well,
some feedbacks. Maybe he's in the room. Let me if you do not mind mute you. Okay. Now please unmute yourself when you talk,
here
okay?
now.
Yeah,
Can you
yeah,
hear me
it's
right?
better. It's better. It's better. I think
Okay,
use
okay.
another mic. You got a microphone system.
So
Now
we have two cameras here, and I have students sitting around me.
all
So
right.
so we use different. I have my laptop, and also we have another one in front of us.
Yeah,
So
the lecture
thank you,
hall,
guys.
yeah.
Yep,
Yeah.
yeah. Okay, I won't take too much time of it. So Q&A or something.
Yeah, let me, if you do not mind, moderate the Q&A section. And so somehow we have very two US students. Maybe they are in class now. This is not a good time for them, and most of them in class. Now, how about this? I would moderate the Q&A section, and since I take that position as moderator because I can take advantage. I can ask questions because I have a lot of questions. So sometimes authoritarian rules here. Guy,
I see. I see.
yeah, yeah. Let me ask a few questions. Some technical, some mostly substantive, and I want to first apologize to the Taiwan students because we have planned to invite Dr. Whitten to come in person to give a talk, and so he can multiple sections for us to learn from him because there's so much we can learn, and it's not a good planning on my part. So, but I want to give the promise now. I will work on inviting Dr. Whitten again in person to visit NCHU, visit Taiwan, and there are a lot of things that we can learn from him, tons of them. Now, my first question is about the compositional time series, and now I think your research. uh, is addressing multiple areas we are in dire need of solutions and answers. So number one is the vote share. It's the vote share, and I think the vote share is I can understand this as a deep zero sum, right? So you cannot have
Yeah.
100 more than 100% of the vote shares. So that is a zero sum, and but the popularity function and also the issue voting and could be a different, could be a different setup. And for example, if you have used the party's popularity as a dependent variable, so that is not a zero sum. And now let's talk about the first uh, area that I think this methodology is addressing, which is how much that we will treat that as flow share, how much all these right-hand side variables, particularly the issues, will affect the composition. And there's a lot of dynamics. And Dr. Wynn only addressed the first selection stage. Then, but later, I think he should have shown more about more dynamics in the voting decision. Now, I want to ask a question, and how much that could be translated into the issue part. And now the issue could be the independent variable, but issue in future could be um, having more impact on the decision making in the budget. For example, I think he has yet to talk about the budget part, and could be that it's about his book. And now I want to specifically ask um, how the dynamics of this only on the selection stage of the parties competitions, and now how could be applied to the uh, Taiwan situation. Now, give you some examples. I want some more background. Taiwan is turning more into more than a two-party system and similar to the British system of two-party plus. But it comes to the presidential election, and the voters get to choose three candidates, and these are real choices. Three candidates. Then in the elections earlier today, this year, 2024, and so it's very similar to somewhat similar to the British system. So British system is parliamentary, and but this one is so in the Taiwan case, it's only one choice, one choice, and of the president. So, but it comes to another is called a party share, or like a party list. Uh, Similar to the proportional representation is the party list that to the to both the presidential elections, sorry, to the legislative elections leeway. And now, uh, uh, let me specifically ask the question: how much that will um, how much you study uh, will shed light on the cannibalization of the opposition coalition. So, say for example, you have a coalition in some parties with similar issue spaces, and then now this in this case in the Taiwan case, the coalition failed to build, and even though they have some similar issues, so otherwise, if the field coalition was made, so that will have a good chance to win the presidential election because they have like a 20 something to 30 something. They added up to be over 50% of the vote shares. And but since the cannibalization, so that means they failed the selection and stage. And so I want you to talk about that, and maybe we do not have the 2024 British data, but that has a lot to do with this, and then I think your model will address the problem. And I think it's the first time I see a model could have provide solutions to address that selection of the voters.
No, I think the Taiwanese case is absolutely fascinating.
Yeah.
Where I think if you had, like, let's say weekly or monthly data on the support for the three parties
Yeah,
over
yeah.
time, and the presidential candidates in particular, you'd be able to see like the trade-offs that voters were making
Yes,
as
yes,
different events happen,
yes.
and
Mhm,
you know, when the the two coalition partners were fighting amongst themselves, you could include that as if you had independent variables that measured their fights or
mhm,
something like that. But you could also look at like how did changes in the economy affect the trade-offs and support
mhm,
across all three of the parties. And since there are two parties that had could have been in coalition together, we would expect that there probably wouldn't be a lot of parameters that would make distinctions
uh,
between the two. Probably
mhm,
more hate or uh, you know somebody said something about somebody. You probably have events that were
mhm,
driving the dynamics between those parties
mhm,
more um, than than probably other indicators that would drive support between them and that party that wasn't.
mhm. Yeah. Then I know
In the
I
Taiwanese
use a lot of
case,
time.
oh, sorry,
Hmm. Yeah. Can I maybe use the time to Taiwan to Peter and his students and
yeah,
do you have any
please.
questions from your students and or your faculty on your side?
Okay, just some quick questions. Uh, I got it. Well, like Carl just commented, this dynamic pi method is groundbreaking. So it's for sure. So we're kind of saying that if the questions are kind of too immature, so please, bear with us. So one of the questions are about the components or components of the modeling. So is the selection of main components generally predicted? I mean, predefined ex ante, or the model is also effective exploratory analysis. That is to identify important components, and then which is also important for policy analysis. So predefined components, or that we can use it as a exploratory to see, for example, this is an education policy, or this is whatever policy it is, and then we try to identify important components. So is the model effective in achieving this purpose? This is the first one. Yeah.
Okay, yeah. So usually you decide which categories of the composition to model based on their presence in the data. So with budgetary data, we use the International Monetary Foundation, IMF's data they have what they call the COFOG data, which are data that are intentionally created to make comparisons possible across countries and over time. And they have 8 main categories of the budget in the time period that we were analyzing. Now, what that means is that you have it's a little bit like the Russian dolls.
Hmm.
You know what I mean? The famous Russian dolls where it's like,
Yeah.
okay, so you have military spending, right? And education and housing and whatever the main 8 are. Um, and and but then inside military spending, we know there's spending on the Navy, spending on the Army, spending on military pensions, right? Uh, so you can kind of keep going down and down, and we've found in practice that our models perform pretty well with 8 categories, even as many as like 12. Uh, but 12, they're not as good. And it just kind of breaks down a little bit in general. But it's usually kind of a data-driven decision. So, if you're modeling vote for parties, if there's one party that kind of always has 1 or 2% of the vote, and another party that always has 1 or 2% of the vote, you might lump them together for your analyses just to make it easier to work with.
Okay,
So yeah.
I see. Carl, is the following question, may I?
Sure,
Yeah,
go
please.
ahead. Please.
All right, it's another question. It's about how do you factor in those independence between whether it's space or intertemporal issues? Because, for example, the neighboring district, voting districts, is there any way that you have, how do you factor in this issue? You know, this interdependence or the independence of different districts, for example.
Yeah. So we have one paper that we published in PSRM on, we call it spatial pi, where we're, and let me see if I can find that real fast. Shoot, let's see. I have that one in these slides. No, that's it. Yeah.
Yes, we see it.
Yeah. That's right. And we were modeling uh, uh, spending in the U.S. states, and so we had I think 10 spending categories across all 50 states, and basically the it's pretty straightforward to do what we call a spatial X model, where we're saying that the in one state can affect the outcome in its neighboring states. Um, the SAR model, where the changes in spending contemporaneously are affecting each other, are really complicated in this space, and we did it, but they're really hard. And then the what we call time lag, spatial lag. So the idea that California's spending changes from last year will affect the neighboring state Oregon's spending in the current year. That we found those models to work really well, but it's just using the standard spatial econometric setup to do it. It's what's it's not particularly hard to get the model to estimate that. What's hard is to do sensible interpretations of the resulting parameters that you get, and that's where I think we've done a lot of these simulations of scenarios that are of interest to people.
Okay, thank you.
Sure.
And then I have a follow-up question. I want to jump onto that if you don't mind, and everyone, sorry. And Guy, I think so that your research is addressing three main directions. One is, of course, the vote choice, and the other one is the issue voting. The third one is the strategic voting or strategic decision from the parties, and at the very early stage of who should run and how they should run relative to the competitors, and some could be rivals, some could be coalition, possible partners, and so I think the first one you only presented this coalition part that some more, for example, and how this uh, dynamic pies could be translated to the issue impacts. So in Taiwan, I think you talk about you basically talk about economics and like economic voting and issue voting too, and that is providing solution to that too. But in Taiwan case, the major issue is how much the future government should deal with China, and one party, and so I said general proposition is to promote independence and de jure independence, and even though some claim that it's a de facto independence, and the other two parties are a little bit different, and they tend to suggest we need to build a better relations with China, and not to be so confrontational. And now this issue, and if you reapply to the dynamic pi, and you can see that some parties are overlap in terms of the just a dynamic overlaps is not necessarily compositional, and so how that could be translated and to that, I think that the charts you presented, and I could imagine some could be not necessarily overlapping the confidence intervals, but they become closer, much closer, and this may get changed, get closer, or get more apart over time, and how much that will be translated into some decisions in other policies and or budgeting, which is not necessarily compositional. I mean, not necessarily in zero sum, right? And so that is something. How would you attack this, or maybe further address this using dynamic pi methodology? Yeah.
Position that we don't need to do the dynamic pi,
Mm,
and you know, that, I mean, there's lots of interesting like scenarios that aren't compositional, of course, um, and and that those could be modeled as systems of equations.
yeah.
I think uh, they're um, they're they're the I think there's there's probably some parts of it that are always going to be compositional in terms of like budgets, right?
Hmm.
Um,
Yeah. Hmm.
you know, and one of the things there is like the whole budget can get bigger or smaller, um, but we still think about the budgetary priorities are
Hmm.
reflected in the relative size. If you're
Hmm.
spending, more on military and less on schools,
Yeah. Yeah. Yeah.
that says something about the whole budget may have gone up or down.
Yeah.
And that's actually something that we got into in our book, where the size of the pie,
Yeah.
when the pie got bigger or smaller.
Yeah.
Um,
Yes.
and
Hmm.
and and what we found was there was still the most interesting variation was in those relative sizes.
Hmm.
In fact, I can show you the whole book was one theoretical figure. So there it is.
Oh. Oh.
Yeah. So it's like we in the we had like an introductory chapter and then kind of an introductory methods chapter, and then chapters 3 and 4 were all the pi models. So we're looking at pi from things affecting it, and then the chapters 5 and 6 were actually a VAR. So this is kind of like what you're talking about, where
Yeah.
we're looking at
Hmm.
external factors, total revenues, total expenditures, expenditure change, budget deficit, all very interesting aspects of budgets that are not compositional. Um,
Hmm. Yeah. Yes. Yes.
I think when you describe, like what you just did, like I see pictures like this, and
Yeah.
some
Hmm.
parts of them are compositions, others are not, and let's go after them. We've got a lot of different tools, and of
Yeah.
course these compositional dynamic models are just one of the many tools that we have available.
Yeah.
Um, yeah, I mean these ideas about parties coming closer or further apart on issue dimensions, I think, are fascinating,
Yeah.
and then make of that. You know,
Mhm.
whether they see
Yeah.
differences between parties when they're close together, when they're far
Yeah.
apart.
Mhm. Yeah.
I mean,
Hmm.
that's a fascinating field of inquiry. And
Yeah.
and I think the other thing in Taiwan that we've talked about doing a paper together on this,
Mhm.
um, and I would love to do that, is
Yeah.
the the combination of you have the regular political economy dynamics that you have in every democracy,
Hmm.
um, but then you also have this huge existential situation,
Exactly. Yeah.
uh,
Hmm.
yeah, and so you have all these events
Yeah.
that we read
Exactly.
about,
Yeah.
all the time in the news. More aggressive behavior, less aggressive, and I
Yeah.
think it's just an incredibly rich set of data that you guys have for
Yes.
analyzing.
Yeah. And a follow up on that, actually, for example, like PLA, People's Liberation Army, uh, getting more intrusion to the air territory of Taiwan. So we have the data over time, like how many aircrafts and then how often and these aircrafts, how many are jet fighters and coming over. These are a good time series data we can incorporate in that model. So that will now on one hand that will see how the dynamic pi and at the beginning of the vote share will be subject to how much existential
Right.
threat from the China side, and so that could be possible impact to the coalition and the opposition, or there could be some good boost to the ruling party, and and then later the budget part, the military budget part, and that is something. I, I want to follow up. Another question is, and I'm still interested in the coalition building and the cannibalizing uh, um, among the oppositions or the coalition partners when they're closer and in their policy on their proposal, etc. And do you have a break point as to how do you know how to do that over time? And this breakpoint suggests that, oh, they decided to build a coalition or decided not to run, not do it their own ways and to continue to stay in the race. And in the British case, they may, I think that the individual race for the parliamentary members uh, could be the single district, single member districts, right? And in the
Right.
presidential race is the same, and in Taiwan. So I really like to see how this uh, uh, um, break point, at what point you can see the coalition building is not is possible, viable, versus then you just see that and continue to do that. It's about the voters, tactical voting or strategic voting, and whether they decided to desert the weaker part of the coalition. And yeah, sorry, I'm asking two questions. One is the party decision whether they can still be the coalition. The second one is if they stay in the race and both stay in the race, and how much the voters will be decided, hey, and it's a waste of votes, and we split the votes between the two supposedly coalition partners, but did not make the coalition, and then they decided to desert and pull the votes into the more viable competitors. Yeah, I think there's some traditionally we just do the multinomial logic and but if we do the time series, these are dynamics. That do we have some methods we can look at a certain strategic point and to the party and to the voters.
I mean, I know there's a guy, Sven Oliver Prokus, who has tried to look at try to use like media coding to to get parties' positions over time.
Uh-huh.
Because we have these like incredibly rich data on manifestos, right?
Uh-huh.
But
Yeah.
those are only at the time of the election. And
Yeah.
so Sven Ollie's work, he's modeled parties' positions over time. So they get sort of a continuous measure of parties' positions. And I think that that would be some incredible data to look
Yeah.
at in the Taiwanese case. I think he's done it in Germany.
Mm-hmm.
Um, uh, I'm trying to remember. I know
Interesting.
they were
Yeah.
working on it. I haven't seen a published paper on that, but it's just using statements made by the parties in the media and then
Mm-hmm.
coding them as like different position taking over time.
Yeah.
But if you
The
can
media
find
and social
out,
media. Like we can we
yeah,
can
yeah,
we can get the data from social media, YouTube, and they see that
yeah, sure,
that kind of like a general sentiments or general uh, uh, tone of voice at over time, and whether this
yeah.
person is getting more adamant or get more soft and on certain issue. Yeah, I think that I do not want to dominate the whole section. And Peter, do we have more questions from the students, and which is more important to address the students' questions?
Yeah, I think the question could be, well, straightforward though. One is that the article they just showed us, guy, by you, Andrew, and other colleague, the comparing thing,
Amanda,
because yeah,
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 Amanda
we haven't
Christine.
read that thoroughly. So one of the students asked that if could you briefly summarize the advantage of dynamic pi and over that cross-sectional, yeah, time series cross-sectional data, yeah, just briefly
Hey,
the
so
advantage for
sorry, uh, I cut you off. What's the advantage of dynamic pi?
that. Just dynamic pi, the advantage of dynamic pi over time
Cross-sectional
series
time series.
cross-sectional data, right? It's
I mean,
it's written
yeah,
in
I
the,
mean,
go ahead.
sorry, we have a lag, so I apologize. Um, I mean, I think the advantage, it depends on the data that you have. If you have a compositional outcome, then clearly you wanna model it as that. And so that's the big advantage of the dynamic pi type of approach. And but as you saw in that last example, those are really just cross-sectional data. The election districts, results by district, but compositional part, so the pie part is the dynamics across districts. And I think the advantage of modeling it as vote for all the major parties together is the advantage of the pie approach. Whereas if you were to use just a standard regression approach, you'd only be able to model, say, the support for the conservatives versus everybody else across districts. So it's to model the trade-offs.
Mm-hmm.
That's really
Mm-hmm.
the big advantage. Yeah.
All right, thanks.
No, actually, this is why we need to bring you here. So to address it and more talking to the students in person and
I'd
more
love to.
it's really good. Yeah.
Absolutely.
Now I have a follow up on that and because so I did a piece of work using isotonic regression. Isotonic regression is and now we can see that data turning from coming from popularity to like a continuous variable to a categorical compositional data, just vote choice, right? Vote choice or vote shares. So so we but it can be also possible a continuous variables is actually categorical. So that means when the popularity comes to a certain point and going down, maybe then that choice could be deserted, and or the other way of come to a certain point, and then and the the consumer or the voter will scrape other choices. And I was talking about, and say we have three parties, and we have KMT, we have the Kuomintang here, and also the DPP, which is the ruling party. Then the third party is called the Taiwan People's Party, and the Taiwan People's Party is emerging, getting a lot of support from the young people and from the middle class. And now at a certain point, and we can see this party, and in 2020, it was not even considered a viable choice. And even though it ran, and the leader ran for presidential race, and but it's not considered a viable choice. Now and then in 2024, so he was serious and doing a lot of great campaign, and then so he became a viable choice. And the viable choice means, oh, that the voters are really considering seriously this person can be our president. And then the second thing we need to account for is uh, um, whether we should wait for a coalition between KMT and TPP, and about I think like a few months, maybe 4 or 5 months in advance, that they decide not to build a same ticket. So that make things change. So I'm thinking about voters' decision here, a guy, and then see how much the voters are uh, thinking about this as a compositional variable, or as just a popularity function. So so that is uh, um, something I think we can look closer when we meet in person, or we come to give a talk in
Yeah.
person. Can you give us more guidance as to how we can see this models and voters' choice, and whether this is a zero-sum game to them, or and they can still if it is the late latter, like a popularity, so that means they will split the votes. They split the votes, right? And 30% support the TPP, another 32% support KMT. They just vote accordingly, right? They vote accordingly instead of thinking about it whether this is and I know that you can think about it strategic voting, but so we can see that, and we see the dynamic pi over time, and maybe in the 3 months, 4 months, or maybe 2 months ahead of the election. So how much we can model that decision from the voters. Yeah, I'm thinking out loud. I'm not sure if I can convey the question clearly to you. So, but anyways, and anything you weigh in, anything you guide us would be great. Yeah.
I know you guys have incredible data, and no, I'm really excited to do a
Yeah,
dynamic pi paper of Taiwan.
that would be wonderful. That would be wonderful. Yeah, yeah. And yeah, sometime after this we can talk, and whether we can start this project with Eric, your student, and
Yeah,
then we have the
perfect.
data. Yeah, then we can really apply this new technology, new methodology to the Taiwan case. I think it will be super interesting, and it's super interesting. Yeah,
Yeah, no, I agree. I agree.
yeah, yeah.
Yeah.
All right, Peter, or any Taiwan students on follow up with more questions?
Yeah, just to follow up, maybe it's for either for Guy or for Carl, and it's
Mm,
about, you think this machine learning can incorporate machine learning into the dynamic pi? Because like, well, it's just a general question. Because there's so many computational things here involved in this modeling. So the machine learning can play a role in this to either advance the modeling, or just a quick question. So
mhm.
either Guy or Carl, can you get a comment of that? on that. So,
And yeah,
I'm sorry, the question is like, what do students have to know to be able to do this, or?
no, because we've been talking about the machine learning thing, and then is it possible, or how do we incorporate this in developing things, technology or things or skills, and then try to use it, try to improve it, improve the model, or you know, this is just maybe this immature question though, and but how can we combine this too? Well, I have to admit, first of all, we have to understand the dynamic pi first, right? And then we want to advance it, and then machine learning could be, is it possible while using machine learning try to improve or advance this modeling, for example, the prediction, things like that.
Right, right. Yeah, I think there's always the potential. I mean, one of the ways you could, the whole machine learning space is just evolving really fast. Um, I uh, I think there's a lot of things you could do creating data. Um, I mean, in terms of harnessing computational power, these simulations that we're doing, you know, are a great example of that, where you can now run things on a laptop, these types of simulations where, when I was a graduate student, you would have had to run them on a mainframe. So on a computer about the size of my house, and it just what the software wasn't out there to do it, and now you can do it on a laptop, which is really amazing. Um, I think machine learning stuff that I'm really familiar with, seen anything where it can take into account like the compositional nature of a covariate. It doesn't mean there's nothing like that out there, but I've just never seen it. Like in a neural net, or something like that. Um, there there probably are, because there's lots of compositional variables out there that people are interested in. I just haven't seen it, but
mhm,
it certainly seems, if nobody's done it, it would be a
no,
really cool thing to do.
no. Uh, um, my observation is I think there's a how many right-hand side variables you can really include to do all this uh, uh, prediction. This is a prediction base, right? And on the right-hand side variables you can do it. But Dr. Whitten's research is already information rich. That means it's really focused on a theoretical, sensible dynamics of this, and so this is already targeting the most important variables. And of course, there could be some other variables we could have missed, we do not have, and we can try maybe stock prices or other media sentiments, and to see we can improve the prediction. And but I think the focus is Dr. Witten's research is really theoretically strong, and it's already theoretically strong, and so that is more focused on the dynamics of these theoretically strong variables, and how much they could see that the implications, and it's a thick model to explain than to predict. And of course you can use that to do the prediction, and use a different kind of algorithm selection. And but this is a really strong algorithm already, in my opinion, and because it's from the start it's theoretically strong, and maybe we can the idea is not to better explain, but to better predict, maybe using already strong variables here to do the prediction. And I wouldn't see there's much improvement in terms of prediction. Maybe unless we miss a really important issue variable, or very important uh, um, party that we overlook, but which is unlikely in the latter case, right? So all the parties, then they are very eager coming to the competition, and unless as one later all of a sudden they she or he and exit the race for scandals but that is very unlikely when it comes to the later part of the election. So I think this is a, but I think I want to highlight or emphasize this is a very promising, particularly in the Taiwan data, very promising methods, and could be addressing some of the questions. So postulating for years, and we have yet to come to a really good or consistent solution. I think this is a promising direction we are looking at, and that can help solve the problem, particularly about how much the voters are thinking about the Tongdu or the independence unification variable could be important in the selection stage, and then could be important in the final decision. And so the external factors from China is really determining maybe, and we can find out with this method. Yeah.
Sure. I mean, prediction is always a good thing to do when you have a time series model to
Yeah.
see how well it does predicting. I mean,
Mm.
uh,
Yeah.
we haven't
Okay.
done a lot of it, but
Yeah.
but I think it would be really interesting to do that. So that's a good
All right.
idea, Peter. I
Yeah.
appreciate it.
Yeah.
Okay. I think it's already 11:47 here a.m. and it's getting late in Texas too. And may I ask if we have some last questions from the student side or from Peter? All right. If not,
Okay,
Guy, I need to contact you further and start planning for inviting you and also talking about the
sounds
project.
great.
Yeah, using the Taiwan data for using the dynamic pi methods for the Taiwan data and having your student to help you. And let me ask one personal question. Are you planning to go to the Texas methodology for conference
Yeah,
in Houston?
always.
Yeah,
Yeah,
do you think we can make it to that and we're too soon?
sure, sure. Yeah, if we get the
Yeah.
data.
Yeah, let me work with Eric and you and see if we can get the data. We have tons of data, and so there may be some. I can even come down to A&M to have a meeting with you,
That'd be
or
great.
we get you online. It'll be very exciting, and
Yeah,
to work on this. Yeah. All right. So Peter,
great.
yeah.
Yeah. All right. No more questions, but just a quick
Great.
announcement for our our next speaker. So Carl has contact and invite Dr. Michael Alvarez from Caltech.
Okay.
So
Okay.
yeah, he's going to share some information with us because he's working with this colleague on this election thing. So I think it would be fun. The date is December 5th, U.S. time. So here in Taiwan, it was December the 6th.
6.
So yeah, stay put and stay tuned. We will send out the invitation. I think you did, right, Carl?
Yeah. And
Yeah. So
yes,
please
you did.
at your convenience, and then come back. I think that will be another very interesting topic, and then to know about. With his doctor student, I believe the Jacob Moria. Yeah, so they're gonna present. Let me see the title. Uh, the GPU accelerated record linkage in Python. So this sounds very technical, but I do think that this is it could be very insightful. And at the same time, I have to personally thank Dr. Professor Guy Whitten and to come up here again. And really, I was hoping that you would be here with Carl and me and then my students. But let's look forward to the next time maybe. Okay. Make
A guy
sure
in
that
there. Yeah.
yeah, and there's no banquet that you have to go or things like that. Okay, thank you.
Yeah, in our appeal,
Good to
guide,
see you guys.
we have the best food and best drinks and best hospitality here in Taiwan.
Sounds great. Sounds great. Can't wait to get there.
Okay, look
Yeah,
All
forward to
right.
seeing you soon.
Thank you guys. All
Thank you
right.
yeah.
again,
See you
Dr.
soon.
Whitten. Appreciate it.
Thank
All
you.
right.
Good
All
to
right.
see you guys. Thank you.
Thank
Thank
you.
you,
Have a
Peter.
good night. Have a good night.
Well,
Good night.
bye.
Good night. Bye.
Bye. Bye all.